Welcome. This video covers the basics of network address translation. Network engineers developed a method to stretch the limited IPv4 address space called network address translation, or NAT. NAT allows a large group of private users to access the Internet by sharing one or more public IP addresses. We know that each subnet creates a separate network. Routers are required to route between subnets on an internal network regardless of whether the IP address range is public or private. However, private networks cannot be routed across the public Internet. So, networkers can enable network address translation, or NAT, on the device connecting the private network to the ISP network, and this is typically a router. This allows many users on a private network to use a few public IP addresses. In order to understand how NAT works on a router, there are a few terms you need to know. It gets a bit confusing sometimes, so don't hesitate to replay this part of the video as needed so you can clearly understand the terms. The inside local network refers to any network connected to a router interface that is part of the privately addressed LAN. Hosts on inside networks have their IP addresses translated before they're transmitted to outside destinations. An outside global network refers to any network attached to the router that is external to the LAN and does not recognize the private addresses assigned to hosts on the LAN. An inside local address is the private IP address configured on a host on an inside network, and this address must be translated before it can travel outside the local network. In this case, it would be the 192.168.1.106 address of the host on the inside local network in this graph. The inside global address is the IP address of an inside host as it appears to the outside network. So this is the translated IP address. In this case, either one of the 209 addresses in the NAT address pool would be an inside global address. The outside local address is the destination address of the packet while it is on the local network. Usually this address is the same as the outside global address, which is the public IP address of an external host. And this address is allocated from a globally routable address or network space. Now that you understand the terms, let's look at how NAT addresses can be assigned. NAT can be deployed either dynamically or statically. First, let's look at dynamic NAT. Dynamic NAT occurs when a router assigns an inside global address from a predefined pool of addresses to an inside private network device. As long as the session is open, the router watches for the inside global address and sends acknowledgments to the initiating inside device. When the session ends, the router simply returns the inside global address to the pool where it becomes available for another privately addressed device to use. One of the advantages of using NAT is that individual hosts are not directly accessible from the public Internet, which provides a level of security. This positive can become a problem if one or more of the hosts within a local private network are running services that need to be accessed from the Internet, such as an FTP server. One way to provide access to local hosts from the Internet is to assign the device a static address translation. Static translations ensure that an individual host's private IP address is always translated to the same registered global IP address. It also ensures that no other local host is translated to the same registered address. Both static and dynamic NAT can be used at the same time if necessary. A variation of NAT is called PAT, or Port Address Translation, also sometimes called NAT overload. An organization which has a very small registered IP address pool, or perhaps even just a single IP address, can still enable multiple users to simultaneously access the public network. PAT translates multiple local addresses into a single global IP address. It manages this clever trick by assigning an IP address and a port number combination to keep track of each individual conversation with the destination host. In PAT, the gateway translates the local source address and port combination in the packet to a single global IP address and a unique port number above 1024. Although each host is translated into the same global IP address, the port number associated with the conversation is unique. People access the Internet from private networks without ever realizing that the router is using NAT. As helpful as NAT is in getting more from the limited IP addressing range available in IPv4, an important issue to keep in mind when designing a network that uses NAT is the additional workload put on the router to support IP addresses and port translations. Network engineers need to choose routing equipment with enough processing power and memory to handle the work. You can see that NAT implementation is a helpful option for network engineers, but it requires good network design and accurate configuration.